Dear students, let us see some more questions from exercise 5.1. Fourth question is, if a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to 1/2 AB. And we have to draw a figure also and we have to explain. Let us see how we will explain it. Here you can see one figure. This figure you can see. In this figure, we have C, a point lying between A and B. And also we are given this condition that AC is equal to BC. If we add AC both the side to this, then AC plus AC is equal to AC plus BC. And as per that assumption of number 4, we can see that AC plus CB. On this, AB is lying on this AC plus CB. That means AC plus BC is equal to AB. So, for this AC plus BC, we can write AB. And if we write here and here AC plus AC, 2AC. So, AC is equal to 1/2 AB. It is proved. Now, question number 5. In question 4, point C is called a midpoint. Suppose that if C is given midpoint of the line segment AB, prove that every line segment has one and only one midpoint. To prove this, first of all, what we will do? We will think for a false statement. That means we suppose for a false midpoint. Here, we will suppose like that. D point is a midpoint of AB. C is not a midpoint, but D is a midpoint. And according to midpoints condition, AD is equal to DB. We can write AD is equal to BD this way. But here it is given that C is a midpoint. So we can write that AC is equal to CB. Now let us add them. AD plus, let us subtract them. AC minus AD is equal to CB minus DB. On subtracting, we can say that AC minus AD is DC. And also CB minus DB is minus DC. Again, you can see that AC minus AD. AC minus this AD. So we will get DC. Again, you can see that CB minus DB, that is DC only. But here smaller, we are subtracting bigger line from smaller line. So it will be minus DC. If we move DC this side, then we will get 2DC is equal to 0. So DC is equal to 0. That means D point is coinciding with C only. So C is equal to D. Both the point are same. And we assume that D is a midpoint. And if D is equal to C, then we can say that C is a midpoint. And this way we can see that only one point we may have as a midpoint for line segment. So it is proved. Question number 6. In figure, if AC is equal to BD, then prove that AB is equal to CD. So let us prove it. Here we are given that AC is equal to BD. AC is equal to BD is given. And AC is equal to AB plus BC. You see the figure, then you can understand that. With the help of figure, you can understand that in this figure, AC is equal to BD, and so for BD we can write that AB plus BC. If we write this, then we can write that BD is equal to BC plus CD. B point is lying between A and C. So AB is equal to BC and AC is equal to BD also. We get these two equations, and if we compare them, then we can write that BD is equal to BC plus CD. So this way we can say that substituting this AC and BD from 2 and 3, equation number 3 and 1, we get that AB plus BC is equal to BC plus CD. Here let me explain with a figure. Suppose in your textbook this figure is like that. A here, B point here, C point here, and D point is here. And now what we concluded, AB plus BC is equal to BC plus CD. So now subtract BC both the side this way, then you are getting AB is equal to CD. So we can say that we have proved this, that whatever we need to prove. Now question number 7 is, why is assume phi in the list of Euclid's axioms considered a universal truth? Why? This assumption is like that the whole is greater than the part, and we can see that if a whole thing is there in universe, in world, anything that is whole, it is greater than its parts. If we cut apple, we have discussed last time. If you tone the chocolates, then also it will become parts, but it is not bigger than its whole part. So it is called universal truth. Now let us see exercise 5.2. Only 2 questions are there and very simple. First question is, how would you rewrite Euclid's fifth postulate so that it would be considered to understand it? For that, many students can give answer on their own. Different type of answer may come. But some 2 examples I am giving here. First is, there is a line through P which is parallel to L, and second point is, there is only one such a line. So, and in this second question, does Euclid's fifth postulate imply the existence of parallel lines? Explain it. Yes, we can say that. In one question also, we see that if a line is there and a point is there which is not on this line, then from this line we can draw a parallel line this way. So in Euclid's this fifth postulate also they tell about this parallel line, and they are also explaining the existence of parallel line.